Welcome to Supply Chain Management. In this video, we will discuss the first of three forecasting methods that we'll cover in this class, which is the simple moving average, or SMA. Now, we will discuss two types of moving averages, and the moving average model uses what we call the last T periods to predict demand in period T+1. So don't get worried, don't get scared if this sort of lingo sounds a bit scary. It's actually fairly straightforward. This means that we're looking at a certain amount of T stands for time. We're going to look at a certain amount of data points in the past to predict demand in the next period, so to predict the next data point. And I'll give you an example shortly so that will be clear in a second. We have two types of moving average models. The first one is the simple moving average, which we'll cover next. And then in the next video, we'll discuss the weighted moving average. Both models are based on the assumption that the most accurate prediction of demand is just a simple or a linear combination of past demand. Now, let me show you exactly what the simple moving average looks like. This is the formula, and before I go into it, and I'll show you how much easier it is than it looks, let's look at what each of the letters means in here. So T indicates the period for which we want to predict the forecast. So for example, F stands for forecast. So F of T would be forecast for example, September. That's assuming that September is the next month we have ahead, we want to forecast. The A says for actual sales. So these are the data points that we already know what happens in the past, the actual sales that occurred before. If you recall, when we were looking at this graph in the previous video, this blue data points would be our actual sales, what happened, and our F of T would be the red dot here. So it's the point that we are trying to forecast. And N is the time horizon. It's how far back we want to look. So for example, do we want to predict July based on just, for example, the data point of May and June? Or maybe we want to look at the entire data points that we have, so all the 6 months prior. So N indicates how many of these data points we're going to look at. Let's look at an example. And practice always makes things easier to understand. We have a juice factory which sells bottles of orange juice, and we have 6 months of sales data. We know how we saw from January all the way to June, and our task is figure out what will the forecast be for July. We can ask, we can try to predict this July in, for example, multiple ways, but in this case, we're going to try 2 to start. What about if we use a 3-month simple moving average? And then we'll check what the forecast will be if we use a 5-month simple moving average. If we are to use the 3-month simple moving average, what we'll do, we're saying the forecast of July will equal at what we sold in June, May, and April. So we're looking at this 3 months before, and we divide it by 3. So we're just averaging the number of months that we are using. And if you do the math, you will see that it would be about 1,840 bottles of orange juice. Now, if we are, instead of using a 3-month simple moving average, we use a 5-month simple moving average, all we're going to do is we're going to add a couple months. We say we're going to forecast July by looking at the 5 months prior, from June all the way to February here. And we'll divide it by 5. So again, we're averaging the 5 months that we are selecting. So you can see it's a fairly straightforward average. It's a simple average that we are doing. And when you're using a 5-month moving average, the answer for, in this case, would be 1,901. So you see how these two numbers are actually different. I told you that it's always important to graph what the actual sales and the past sales data when you're forecasting. So let's do the same. That's what I try to accomplish here. We have in the blue line, so this blue line here, matches this second column. That's the actual demand. So that is what actually occurred. And the orange line is actually depicting the 3 months simple moving average. You can see that it starts in April because I needed 3 months of data before I can start calculating this forecast. So here we have 1,191, and this would correspond to this dot right here. Similarly, the gray line instead represents the 5 months moving average. And here it starts later in June because, of course, to do this formula, I need 5 data points. And so I'm averaging January through May to predict June. So this 1,940 would be this dot right here. And what you notice is that when you're trying to follow, right, we're trying to really predict as accurately as possible the blue line, what actually happens. And what you see is that the orange line actually follows the blue line much more closely than the gray one. What we're actually saying is that the 5-month average smooths the data more. So when there is a change in trend, like here, sorry, going down and then going up, a larger amount of months used in your average reacts less to these changes. So it smoothens the data more. On the other side, instead, if you use a smaller number of months, like you do a 3 months average compared to the 3 months average, excuse me, is more responsive to this change in trends. You see, that's why it reacts sooner. So it switches, it moves up faster than the gray line. Keep this in mind because in the exam, you often will have this kind of questions and not just a calculation question. Now let's give one more example. Here I want to ask you, we did a 3 months simple moving average and we did a 5 months simple moving average. And here we have the two numbers we calculated. What do you predict would be the forecast if we use a 6-month simple moving average? Do you think would be a larger, higher number than July of the 3 and 5 month simple moving average, or would be smaller? Well, if you said larger, you would be right. So here's the calculation. We are averaging all of the months we had available, January through June, and the average is 1,916. Again, this shows that a larger amount of months used in this calculation, then the least you react to the change in trend. And because we use so equal weights, so every month was worth the same as the others, then the downward trend, so this trend we can see here, you see that in February was quite high, we started with 2,000, then we went down, further down, up to 1,793 in June. So this downward trend we see in the actual sales data is not observed when you have a larger amount of months in your average. When we're trying to discuss about equal weights, keep it just in mind, this will be our link to the weighted moving average, which we will discuss in the next video. For now, as a summary, we discussed the simple moving average method, and I'll leave you with 2 knowledge checks right now because you get 2 types of questions for any of the calculations, any of the formulas in this course. The first one is this one, a very straightforward calculation question. Given the sales data in this graph below, do you see it looks like for 6 months we sold 10 units, and then in July we sold 30, and then 50 in August. Using a 3-month simple moving average, what is the September forecast? What would it be the September forecast if you use a 5 months? And what if you had a 7-month moving forecast? You can pause this video briefly, you do your calculation, then you can check your answers here at the bottom of the slide. And in the meanwhile, I want to present to you with the next knowledge check, which is with the same data points here, so the same 10 units for the last 6 months, plus a 30 and a 50 for July and August. Which forecast method would be more reactive to this trend change? Would be the 3, the 5, or the 7 month? Think about it, and the answer is here at the bottom.